Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. The Milky Way, our home galaxy. The Milky Way is the galaxy that contains our solar system, along with billions of other stars, planets, and cosmic structures. It is one of the many galaxies in the observable universe, and part of a larger structure called the Laniakea supercluster. In this podcast, we will explore the origin, structure, composition, and evolution of the Milky Way, as well as some of the fascinating phenomena and mysteries that it harbors. Origin and history. The Milky Way is estimated to be about 13.6 billion years old, slightly younger than the age of the universe itself. It formed from the gravitational collapse of a large cloud of gas and dust, shortly after the Big Bang. The first stars and clusters in the Milky Way were metal-poor, meaning they had low amounts of elements heavier than hydrogen and helium. These stars enriched the interstellar medium with heavier elements through stellar nucleosynthesis and supernova explosions. The Milky Way gradually grew in size and mass by merging with smaller galaxies and accreting gas from the surrounding environment. The Milky Way has experienced several major events that shaped its history and appearance. About 10 billion years ago, it collided with a galaxy called Gaia Enceladus, which triggered a burst of star formation and created the thick disk of the galaxy. About 6 billion years ago, it was perturbed by the passage of the Sagittarius dwarf spheroidal galaxy, a satellite galaxy that is still orbiting the Milky Way today. This caused ripples and waves in the disk of the galaxy, and may have contributed to the formation of the spiral arms. About 4.5 billion years ago, the solar system was born in the Orion arm of the galaxy, a minor arm located between the two major arms. The solar system has since completed about 20 orbits around the center of the galaxy, at a speed of about 220 kilometers per second. The Milky Way is currently interacting with another large galaxy, the Andromeda Galaxy, which is about 2.5 million light-years away. The two galaxies are approaching each other at a speed of about 110 kilometers per second. And are expected to collide in about 4 billion years. The collision will result in a massive merger that will create a new elliptical galaxy, sometimes called Milkomeda or Milkdromeda. The fate of the solar system in this merger is uncertain, but it is likely that it will be ejected from its current position and move to a more distant and chaotic orbit. Structure and composition. The Milky Way is a barred spiral galaxy, meaning it has a central bar-shaped structure composed of stars and spiral arms that extend from the ends of the bar. The bar is about 27,000 light-years long, and is surrounded by a ring of gas and dust called the 5-kpc ring. The spiral arms are regions of higher density of gas and dust, where star formation is more active. The Milky Way has two major arms, called the Scutum Centaurus arm and the Perseus arm, and two minor arms, called the Norma arm and the Sagittarius arm. There are also smaller spurs and branches that connect the arms, such as the Orion arm, where the solar system is located. The Milky Way has a disc-like shape, with a diameter of about 170,000 light-years and a thickness of about 1,000 light-years at the spiral arms. The disk is divided into two components: the thin disk and the thick disk. The thin disk contains younger and more metal-rich stars, and is the site of most of the star formation in the galaxy. The thick disk contains older and more metal-poor stars, and is the remnant of an ancient stellar population. The thin disk and the thick disk are separated by a scale height of about 300 light-years, meaning that the density of stars drops by half for every 300 light-years above or below the midplane of the disk. The Milky Way also has a spherical component, called the halo, that surrounds the disk. The halo contains globular clusters, which are dense groups of old stars that orbit the center of the galaxy. The halo also contains individual stars, mostly metal-poor and low-mass, that have high velocities and random orbits. Some of these stars are believed to be the oldest in the galaxy, dating back to the early stages of its formation. The halo has a diameter of about 200,000 light-years, and a mass of about 10% of the disk. The center of the Milky Way is a region of high density and activity, where a supermassive black hole resides. The black hole, called Sagittarius A*, has a mass of about 4 million times that of the Sun, and is surrounded by a rotating disk of gas and dust that feeds it. The black hole is also orbited by a cluster of stars, some of which have very close and fast orbits. The center of the galaxy is also the source of powerful emissions of radio, infrared, X-ray, and gamma-ray radiation, as well as jets and winds of particles that influence the surrounding environment. The Milky Way is composed of different types of matter, both visible and invisible. The visible matter includes stars, gas, dust, and planets, which make up about 15% of the total mass of the galaxy. The invisible matter includes dark matter and dark energy, which make up about 85% of the total mass of the galaxy. Dark matter is a mysterious substance that does not interact with light, but has gravity and affects the motion of visible matter. Dark energy is a mysterious force that causes the expansion of the universe to accelerate. The nature and origin of dark matter and dark energy are unknown, but they are essential for explaining the structure and evolution of the galaxy and the universe. Evolution and future. The Milky Way is a dynamic and evolving system, constantly changing its shape, size, and composition. The galaxy is influenced by internal and external factors, such as star formation and death, stellar feedback, galactic rotation, gravitational interactions, and cosmological expansion. The galaxy is also subject to various hazards and threats, such as supernova explosions, gamma-ray bursts, rogue stars and planets, and galactic collisions. The Milky Way is currently in a relatively stable and quiescent phase, with a moderate rate of star formation and a balanced budget of gas inflow and outflow. However, this situation may change in the future, as the galaxy encounters new challenges and opportunities. Some of the possible scenarios for the future of the Milky Way are: 1. The Milky Way will continue to merge with its satellite galaxies, such as the Large and Small Magellanic Clouds, the Sagittarius Dwarf, and the Canis Major Dwarf. These mergers will bring fresh gas and stars to the galaxy, and trigger episodes of star formation and activity. However, They will also disrupt the structure and kinematics of the galaxy, and create tidal streams and debris around it. 2. The Milky Way will collide with the Andromeda Galaxy, as mentioned before, in about 4 billion years. This will be a major event that will transform the galaxy into a new and larger elliptical galaxy. The collision will induce a burst of star formation and activity, as well as gravitational waves and radiation. The collision will also affect the fate of the solar system and other planetary systems, which may be ejected, captured, or destroyed by the merger. 3. The Milky Way will face the effects of the accelerating expansion of the universe, driven by dark energy. This will cause the galaxy to become more isolated and detached from other galaxies, as the space between them grows faster than the speed of light. Eventually, the galaxy will lose contact and visibility with the rest of the universe, and will only be able to observe its own gravitationally bound structures. The galaxy will also experience a cooling and dimming of its stars, as they age and consume their fuel. The galaxy will enter a phase of heat death, where no more stars or planets can form, and all forms of energy and information will be lost. The Milky Way is a fascinating and complex system that offers us a glimpse into the history and diversity of the universe. It is also our home and our destiny, as we are part of it and influenced by it. By studying and exploring the Milky Way, we can learn more about ourselves and our place in the cosmos.